Hello everyone. So this lesson we didn't get to during the chapter 3, but it discusses the imaginary number I, which is defined as the square root of -1. Now, what you have to remember is when we did the square roots, by definition of square root, if a squared equals b, then the square root of, b is equal to a, meaning what to the second power gives you the number inside. Well, if that number inside is negative, there are no numbers, right, that you could raise to the second power and get a negative because it'll always be positive. Therefore, we have to have something in place of the square root of -1. Okay, so what do? Well, first off, when we talk about the square root of -1, we have another name for it, and it's called the imaginary number I. So anytime you see the square root of -1, we can replace it with I. Now up here, when we see I squared is -1, root -1 times root -1, which just gives you -1. So we basically say I is the square root of -1, and I squared is equal to just -1. Now what does this all mean? Well, when we go to simplify these radicals, right? I'm going to break this up into the square root of -1 times the square root of 25. And if you remember from simplifying radicals, the square root of -1 is just going to be I. The square root of 25 is 5. Therefore, we leave this as 5I. Okay? The next one. The largest perfect square that goes into 52. The largest perfect square that goes into 52 is 4. And that's going to be 4 times 13. Sorry. So now when we go to simplify this, we're going to break it up into root -1 times root 4 times root 13. We get root 4 becomes 2. And whenever you see the square root of -1, all we're going to do is put I, then we bring down the square root of 13, and you are done. Now when you look at the next one, root -17, well, 17 cannot be simplified, so we'll leave it inside the radical. We're going to say this is I root 17. So when we combine terms with i's, if I have like 6i plus 3i, I can combine them like x's to get 9i. So when I look down here, root -25, that's going to become 5i plus root -64 is 8i. And now when I combine these, I would get 13i. Okay? Now the next one, when we simplify each of these terms, when you're adding, you have to simplify them first. So root -1 times root 25 times root 2. So this here will simplify to 5i root 2. And then when I go to do this one, we're going to do root -1 times root 64 times root 2. So it's going to give me plus, this becomes 8i root 2. And now since root 2 is in both of these, we're going to say 5 plus 8 is 13. And you have your I and then your root 2. So the next one, we're going to simplify this. The largest perfect square that goes into 75 is 25. So we're going to break it up into root -1 times root 25 times root 3. This will become 5i root 3. And when I look at the other one, the largest perfect square that actually goes into that is 49. So we would do root -1 times root 49 times root 3. This becomes plus 7i root 3. And now I can combine these like terms. 5 plus 7 gives me 12i root 3. and I am done. So here, root 27 simplifies to root 9 times root 3. So you get 3 root 3. Then root 75 becomes root 25 times root 3, which is going to give you 5 root 3. Are these like radicals? Yes. So we can combine it to get 8 root 3. Now the next one, right? How does root 80 break up into? It's going to be root 16 times root 5, which gives you 4 root 5. And this would be root 100 times root 5, which gives you plus 10 root 5. And now 4 plus 10 gives you 14 root 5. Okay, and then the last one here, we know that's root 4 times root 6, so 2 root 6. Then 486 the next one is root 81 times root 6, and that would give you 9 root 6. But if you look at this now, these are not like radicals, so you cannot combine them any further. So you would leave your answer like this. Okay. Now, just like we said above, anytime we see I, we're basically thinking that's root negative 1. Okay. But when we get I squared, we know that translates to negative 1. But I to the third, what's root negative 1 times root negative 1 times root negative 1? We know this gives us negative 1 times root negative 1. And how do we simplify root negative 1? We're going to say that's negative 1i, or just negative I. And I to the fourth, when we multiply these all out, root negative 1 times root negative 1 times root negative 1 times root negative 1, you should know that this gives you negative 1 times this gives you negative 1. Negative 1 times negative 1 is 1. So this right here basically helps you figure out what all of this means. Now what I like to do is figure out how many I to the fourth, because anytime I see I to the fourth, it gets replaced with 1. So when we go to do a problem like number 1 here, what we're trying to do is figure out how many I to the fourths go in here. So what I do is I take 11, the exponent, and divide it by 4. 4 goes in 11 2 times, and my remainder would be 3, because 11 divided by 4, you get 4 goes in 11 2 times. 2 times 4 is 8. When you subtract, you get a remainder of 3. So we're basically saying this is I to the 8th times I to the third. Well, because this is divisible by 4, we know that's 1, and I to the third would just leave me with, what is I to the third up in the chart above? Negative I. So I would do 1 times negative I, which is just negative I. Okay? I to the 33rd. If I do 33 divided by 4, I know 4 goes into 33 8 times. 8 times 4 is 32. When I subtract, I get a remainder of 1. So what this ends up being is I to the 32 times I. I to the 32 is just 1, right? And 1 times I is just I. Done. Okay? I to the 66th. Well, 66 divided by 4. 4 goes into 66. What would that be? 15 times? No, 16 times. 16 times 4 is 64. When you subtract, you get a remainder of 2. So this is technically I to the 64th, which becomes 1, times I to the second. What is I to the second equivalent to? Negative 1. And I'm getting those all from the charts up here. I to the first is I squared is negative 1, I to the third is negative I to the fourth is 1. The next one, 51 divided by 4, right? 4 goes into 51 12 times. 12 times 4 is 48. I get a remainder of 3. So this is basically equivalent to I to the third, which gives you negative I. Remember, it's always the exponent. Your remainder becomes your exponent that you're simplifying. So over here, what do I get when I multiply these all out? This is where I add the exponents. And that would give me 5 plus 17 is 22, plus 2 is 24. Now, what is 24 divided by 4? 6. So this basically comes out even, so your answer is just 1. The next one, when I add the exponents here, I get I to the, what is that, 38 plus 1, I to the 41. 41 divided by 4, it goes in 10 times. What's my remainder going to be? 1. So what is I to the first is just I. And when I go to do these down below here, when we're multiplying now, we know this is going to translate here to root negative 1 times root 25. So that's going to give me 5i. Now, how do I do root negative 64? That's going to be 8i. When I multiply these, 5 times 8 is 40. I times I is I squared. But what can I replace I squared with up in this chart? I squared is equal to negative 1. So I'm basically going to do 40 times negative 1, which gives you negative 40. The next one, I'm going to raise 3 to the third and I to the third. 3 to the third is 27. I to the third, if you go up to that chart, is going to be equal to negative I. So 27 times negative 1 is negative 27i. Root negative 7 times root negative 7, you should know right away that's going to give you, basically, if you think about it, root negative 1 times root 7, so it's I root 7 times I root 7, which gives you I squared root 7, but I squared translates to negative 1 root 7. Oh, sorry. Okay. So the next one, you get 3i times 7 to the second power is 49. I to the second power is I squared. So you get 3 times 49, right? 3 times 49, which is 147. I to the third, well, we want to know that that's going to be 147 times negative I. And that would give us negative 147i. Number 5, 5i times 5i, if you think about it, would be 5 times 5 is 25i squared, but I squared becomes negative 1, and that would give us negative 25. Now, when we solve quadratics with this, if this video runs out, I will finish it, so there will be a second part to it. We remember solving, actually, I'm just going to go ahead right away and start the new video with all of this.